In recent years, many large offshore and onshore production facilities containing riser pipes have been constructed. Shown here is a trunk line coming from offshore to an onshore separation facility. Here we see an example of a trunk line or pipeline connecting with a riser pipe, which in turn connects with separation facilities on an offshore platform. In certain ranges of gas and liquid flow rates, extremely long liquid slugs can be caused by the riser pipe. One technique for eliminating large slugs has been to choke the flow at the top of the riser pipe. Reductions in flow rate up to 70% have been reported with this technique. A pipe system, shown here, was constructed. The system consisted of transparent 2-inch diameter pipe with a 100-foot pipeline terminating in a 50-foot vertical riser. As the liquid bridges the pipe at the connecting elbow, the liquid begins to accumulate in both the pipeline and the riser pipe simultaneously. The free passage for air into the riser is thus blocked, and the pressure in the pipeline, shown as P-pipe, begins to increase. A simple force balance, ignoring friction, shows that the hydrostatic head in the riser equals the sum of the hydrostatic head in a pipeline and the pressure force from the gas acting on a cross-sectional pipe area. The process continues until the liquid slug reaches the top of the riser pipe, at which time the pressure in the pipeline reaches its maximum value. The pressure in the pipeline then begins to drop because the slug length gradually decreases as the slug passes out of the riser and into the separator. When the tail of the slug reaches the top of the riser pipe, the pressure in the pipeline drops to its minimum value. The preceding description of severe liquid slug formation and production will now be shown with an actual experimental test conducted on the Fluid Flow Project's pipeline riser pipe system, with the pipeline inclined at an angle of -5 degrees from the horizontal. The test begins immediately after a liquid slug has passed into the separator and a new slug is about to be generated, starting at the connecting elbow. Notice how the liquid slug builds up in the pipeline and simultaneously in the riser pipe. Several examples of slugs forming and being produced will now be shown. Here a slug is forming again in the pipeline. Reaches its maximum length when the slug reaches the top of the riser pipe, and then begins to be produced. As the slug is produced, the pipeline pressure drops rapidly to the separator pressure value. The slug is preceded by a heavily aerated foam, followed by kerosene with much less aeration. After the slug is produced, considerable fallback of a foamy kerosene mixture takes place, with the foam becoming part of the next slug. Here we see the foam building up in the riser pipe. And falling back after production of the slug. There's a significantly different color between the foam and the kerosene slug.